Given P is the vector 4, negative 6 and Q is the vector minus 5, minus 1. Find the resultant vector of a half P plus Q, and you've got to express your answer in component form. Component form are those numbers in the bracket. So if we then write down a half of P vector plus Q vector, that is equal to a half, and the components of P are 4 minus 6, and to that I want to add on minus 5 minus 1. Now I'm going to half P first of all, so half of 4 is 2 and a half of minus 6 is minus 3. I've still got to add on the minus 5 minus 1. So when I add them together, I've got a 2 plus minus 5, which gives me minus 3, and minus 3 plus minus 1 gives me minus 4. Double underline your answer. Question 2. I want to evaluate 3/4 of 1/3 plus 2/7. Now in maths you always do the bracket first, so I'm going to add a third and 2/7. Now we need the common denominator, which is 3 times 7, so our common denominator is 21. I then look at the first fraction 1/3. What have I done to that 3 to change it to 21? I've multiplied it by 7, the number that's opposite. So I stay fair with fractions and I multiply the top number by 7. Next fraction I've multiplied by 3, so 2 times 3 gives me 6. Now I've got 7 of them plus 6 of them, and that gives me a total of 13 21s. Now we check our answer is given in its simplest form, and then we've got to finish off the calculation by doing 3/4 times 13 over 21. Now that just means we're multiplying across the top and across the bottom, so it's 3 over 4 multiplied by 13 over 21. Now we have to look and see if there's anything cancels. So if we look at the 3 at the top and the 21 at the bottom, they're both in the 3 times table. So if I divide by 3, then 3 into 3 goes once, and 3 into 21 goes 7 times. So then we've got a nice easy sum to do. We have 1 multiplied by 13 is 13, and 4 7s are 28. Check again that it's in its simplest form. Next one, question 3. The diagram shows a sector of a circle centre C. The radius of the circle is 20 centimetres and the angle ACB is 45. Calculate the area. Now the area of a sector is x divided by 360 multiplied by the area of a circle, which is pi r squared. If we fill in the numbers, x is 45. So we've got 45 divided by 360, and I want to multiply that by 3.14 multiplied by 20 squared. 20 squared is 400. Now we don't have a calculator, this is a non-calculator paper. So I'm going to look to see if anything from the top row will cancel with anything from that 360. And first of all, I can divide top and bottom by 10. So the 400 becomes 40 and the 360 becomes 36. I'll then have another wee look to see what else will cancel. And I know that 4 divides into 36 and 4 divides into 40. So 4 into 40 goes 10 times. 4 into 36 goes 9 times. Now I've got 45 divided by 9. That will divide out, so 45 divided by 9 is 5. So I get 5 times 3.14 times 10. Now if I do the 3.14 times 10, then that gives me 31.4, and then I've got to multiply that by 5. Now do a sum at the side of your page. Right, it's not, you don't have to do them mentally. So 5 fours are 20, put down a 0, carry 2, 5 ones are 5 and 2 makes 7, 5 threes are 15. Now there is one number after the decimal point in the question, I need one number after the decimal point in my answer. So therefore the area of that sector is 157, and the units are centimetres squared. Now that's not the only way that that question can be done. If I think about 45 degrees, if I take 360 degrees going all the way around, there's a 90-degree angle. 45 degrees is half of 90. So going right the way around a circle, right around 360 degrees, I have got 8 45s. So it's really an eighth of the area of the circle. So you could have worked out 3.14 multiplied by the radius squared and divided it by 8. Next question, question 4. Charlie is making costumes for a school show. One day he made 2 cloaks and 3 dresses. The total amount of material he used was 9.6 square metres. Write down an equation to illustrate this information. Now it's really important you say let C equal cloaks, and you can say let D equal dresses. That must be stated in your question. So what have we got then? We've got 2 cloaks and 3 dresses, and the amount of material was 9.6. So if we write that down, we get 2C plus 3D is equal to 9.6. Now likewise for the second one, we've got 3 cloaks and 4 dresses, and the material used was 13.3 square metres. So if we write that down, we've got 3C plus 4D is equal to 13.3. Now that's 2 equations, and we're going to solve a pair of simultaneous equations to work out the amount of material required to make 1 cloak and the amount of material required to make 1 dress. I've written down both equations. So there's equation 1 and equation 2. Now I'm comparing the C terms, so I've got different numbers there in both C and D, and both are positive. Now really what I'm looking for is I'm looking for one that's negative and one that's positive. In this question there isn't one that's negative and one that's positive. So probably the best idea is to eliminate C because the numbers are smaller. So really what we're looking for is we're looking for multiplying the equations by the opposite numbers. So the top equation I'm going to multiply by 3, the bottom equation I'm going to multiply by 2, but one of them's got to be negative, so I'm going to make the bottom one negative. Now when I multiply equation 1 by 3, I get 6C plus 9D, and that is equal to 3 times 9.6, and 3 times 9.6 is 28.8. Second equation I'm going to multiply by minus 2. So minus 2 times 3C is minus 6C. Minus 2 times 4D is plus 8D. Minus 8D, and that is equal to minus 2 times 13.3 is minus 26.6. Now, I want to add those 2 equations together. So when I add them together, C plus minus C is 0, and 9D minus 8D is 1D, and 28.8 take away 26.6 is 2.2. So the amount of material required to make one dress is 2.2 square metres. I now substitute D equal to 2.2 into one of the equations. Now you always choose one that you've not already multiplied, so you wouldn't choose any of those ones that are written there in black. I'm just going to use equation 1, and that is 2C plus 3D is equal to 9.6. Now 2C, I'll write down, 3D is 3 lots of 2.2, which is 6.6, and that is equal to 9.6. Now if I take 6.6 away from both sides, I get 2C is equal to 3, or 3.0. So 1C is equal to 3 divided by 2, which is 1.5. Now the next part is really important. You must make a statement. You can lose 1 full mark if you do not write down the question in the context, or the answers in the context of the question. So you have to say the amount of material required for a cloak is 1.5 meters squared, and the amount of material required for a dress is 2.2 meters squared. If you do not write that down, you will not get the last mark in this question. Question 5. A cattle farmer records the weight of some of his calves. The scatter graph shows the relationship between the age A in months and the weight W in kilograms. Now, those are the important bits. It's the age in month and the weight in kilograms. Now, all of those points are put on the diagram. You can see all of the lots of wee dots all over the place, and a line of best fit is drawn through them. So the line goes through 3 points. There's about 4 points above the line and about 3 below the line. So that's the line of best fit. Now you do not want to know anything about those points that are not lying in the line. The only points that are important are the ones that are on the line. Now you have been given 2 points, D, and you've been given E, and you're given the coordinates of them. So you're told that point D represents a 3-month-old calf which weighs 100 kilograms, and you're told that point E represents a 15-month-old calf which weighs 340 kilograms. Now those are going to be the points that you're going to use. You've got to find the equation of the line of best fit in terms of A and W, and you've got to give the equation in its simplest form. So all of those things, highlight them and make sure when you're doing your final answer that you express them the way that you're supposed to. Right, so 3 points are the points 3, 100 and 15, 340. Label your points. So the first point here is x1, y1, the second point is x2, y2. Your gradient is y2 minus y1 divided by x2 minus x1. Now, when you're labelling them, the first point has got a wee subscript of 1, the second point has got a subscript of 2. It does not matter which one you choose for point 1 or point 2. When you do your gradient formula, they will balance out, so it doesn't matter. Right, so I have now got y2 minus y1 is 340 divided by 100. And that's all divided by x2 minus x1, which is 15 minus 3. That gives me 240 divided by 15 take away 3 is 12. Now 12 into 24 goes twice, so 12 into 240 goes 20 times. So the gradient of this line is 20. We now want the equation of the line, and I know the gradient is 20, and I also know that the equation of a straight line is y minus b is equal to m times x minus a. I've chosen the first point as point 3, 100, and 0.3100, that gives me A and B values. So y minus A, or y minus B is y minus 100 is equal to m, which is 20 times x minus A, which is x minus 3. Now I want to multiply out that bracket, so y minus 100 is equal to 20 x's minus 60. Don't want that to take away 100, so the opposite of taking away 100 is to add 100 onto both sides. So I'm going to add 100 onto the left hand side and 100 onto the right hand side. When I do that, then I have y is equal to 20 x's, and really I've got 100 take away 60, which is plus 40. Now go back, read the question. It's in its simplest form, but I have got to write in terms of A and W. So if I look up, the y-axis has the W, so y is W, so W is equal to 20A plus 40. Now again, you will get one full mark for that changing x's and y's to W and A. Please don't forget to do it. Always finish by going back to read the question. Now for part B, it says use your equation from part A to estimate the weight of a 1-year-old calf. Now the formula we've got is W is 20A plus 40. Now it says a 1-year-old calf, but A is the age of the calf in months, so we have to make sure we write that down as 12 months. Okay, that's another wee trick, or another wee pit there that we don't want to fall into. Right, so 20 times 12 for the age in months plus 40. So 20 times 12, 2 12s are 24, so it's 240. Plus 40 gives me 280, and the units were in kilograms. Double underline your answer. So the weight is equal to 280 kilograms. Question 6. I want to determine the nature of the roots of the function. As soon as you see nature and roots, you're thinking about the discriminant. So you're thinking about b squared minus 4ac. Now, we will look at the quadratic equation and we'll decide which one is A, which one is B, and which one is C. So, write down the side of your page A, B and C. Go back to your equation and we'll fill in those answers. So A is the number of x squareds, so that is 7. B is the number of x's, which is plus 5. And C is the number tagged at the end without x squareds or without x's. So if you fill them in, A is 7, B is 5, and C is minus 1. Now we're going to calculate the discriminant. So b squared is 5 squared, minus 4 times A, which is 7, multiplied by C, which is minus 1. So 5 squared is 25, minus 4 times 7 is minus 28, and minus 28 times minus 1 is plus 28. Be careful when you've got the double negative. We now then just have to add those two values together, so 25 and 28 gives me a value of 53. Now, I have not answered this question. This question asked me to determine the nature of the roots. So you now must answer that question. So b squared minus 4ac is equal to 53. That means that b squared minus 4ac is greater than 0. And that means therefore, that's the wee symbol for therefore, there are two real distinct roots. Now, distinct just means different. They're different numbers. So two roots with different numbers. So there are two real distinct roots. Right, this one, it says the diagram shows a rectangular based pyramid relative to the coordinate axis. Now, if we are looking at this diagram, A is a point 20 and V is sitting right in the middle of that pyramid. That's the peak of that pyramid, so it sits right in the middle. Now if we look at the x coordinate of V, it is 5. So if I drop that down onto the axis, the middle of that pyramid is 5 on the x-axis. If I look at the height of the pyramid, it goes up to the z coordinate is 6. So the height of that pyramid is 6. Now if I look to see how far back it goes on the y-axis, halfway back is 2. The middle coordinate is the y coordinate, which is 2. So all the way back is going to go back 4 units. Now, if we're going from 2 to 5, it's going up 3 in the x-axis, so I've got to go up another 3, which would take me up to 8 to get to that point there in your pyramid. Now, on the y value, it goes back 2 to the midpoint, so to get to B, it must go back 4. Now, if I can piece all of that together then, starting at the origin, to get to B, I've got to go across 8 in the x-axis, and the y-axis I've got to go back 4, and it doesn't come out from the page, there's no height for B as it's sitting in the base, so it's got to be 8, 4 and 0. Now for the next part, calculate the length of the edge AV of the pyramid. Now there's lots of ways you can do this. You can use Pythagoras' theorem. I'm going to draw that line that's represented by AV. I've put in the coordinates. So coordinates of A are 2, 0, and coordinates of V are 5, 2 and 6. Now you could work out lengths and use Pythagoras. I've tried to work out the easiest way of doing this. So if we go from A to V and the x number, it goes from 2 to 5, which means it's gone up 3. If we look at the y coordinates, it's gone from 0 to 2, so it's gone up 2. And going from 0 in the z coordinate up to 6, it's going in the z coordinate, it's going up 6. So that means the components of the journey from A to V is 3, 2 and 6. Now AV then has components 3, 2 and 6, but if I want to calculate the length of AV, that just means the magnitude, and the magnitude is the square root of 3 squared plus 2 squared plus 6 squared. So when I work all of that out, I get the square root of 9 plus 4 plus 36. Add all of them together gives me the square root of 49. So the distance from A to V is 7 units. Question 8. Solve the equation 2x over 3 minus 5 over 6 is equal to 2x. Now, equations with fractions, we don't want to have any fractions there, and we're dealing with thirds and we're dealing with sixes. Now you could multiply by 3 and then see where that takes you, and then if there's still fractions, which there will be, you would then multiply to get rid of that second fraction. But if we use a wee bit of thought, 3 divides into 6. So if I multiply this whole equation by 6, then I should be able to cancel out the thirds and the sixes. So if I multiply by 6, that's really the same as multiplying by 6 over 1. And to multiply fractions, we multiply straight across the top, 2 numbers at the top and 2 numbers at the bottom. So when I've got 2x over 3 minus 5 over 6 equal to 2x, I'll multiply the first number by 6 over 1. When I multiply that by 6 over 1, I get 6 2s are 12 x's over 3 minus 6 5s are 30 over 6, and all of that is equal to 6 2s are 12 x's. Now I can simplify these fractions. That was the whole point of multiplying. So 12 divided by 3 gives me 4, so that's 4x. 30 divided by 6 is 5, and the 12x stays where it is. Now I want to gather all the x's to one side and all the numbers to the other side. So I've got 12x on the right hand side, I have got 4x's on the left hand side, so I'm going to take that 4x away from both sides. Now that leaves me then with minus 5 is equal to 12x taken away 4x is 8x, and if I then read that round the other way, I've got 8x's are equal to minus 5, so x is equal to minus 5 over 8. And that's my answer, double underlined.